Chapter 8, Section 6, Systems of Nonlinear Equations. So what's going to happen here is you're going to get a system of two equations, and either one or both the equations is not going to be linear. See, 3x minus y equals negative 2 is linear because you have x to the first power and you have y to the first power. However, 3x squared minus y equals 0 is nonlinear because the x is squared. So the first thing we're going to do is we're going to do substitution. Because we have y by itself, I'm going to pull this 2x squared minus y equals 0 down, and I'm going to add the y over, so we get y equals 2x squared. And I'm going to take the 2x squared and substitute into for y in the first equation. So 2x squared is going to go in for y, for the 3x minus y equals negative 2. That gives us 3x minus 2x squared equals negative 2x, or equals negative 2. If we use algebra, and remember when you use algebra, you want your x squared term positive. So I'm going to add this over, subtract this over. I get 2x squared minus 3x minus 2 equals 0. This is factorable. So I get 2x plus 1 times x minus 2 equals 0. Set the 2x plus 1 equals 0. I get x equals negative 1/2. Set the x minus 2 equals 0. I get x equals 2. So then what's going to happen is we've only found half of the ordered pairs. Remember, these are ordered pair answers because we've got to find x and y. And again, like I've said before, it doesn't matter if you find y first or x first, you're going to end up finding both. So then what I did was I pulled the original equation, 3x minus y equals negative 2, down. And what I'm going to do is I'm going to substitute negative 1/2 in and solve for y. For y, and I'm going to substitute 2 in for x and solve for y. So here's the negative 1/2. Putting the negative 1/2 in there, we get 3 times negative 1/2 minus y equals negative 2. We get negative 3 halves minus y. I change the negative 2 to negative 4 halves. Add the 3 halves over, we get negative y equals negative 1/2. We get y equals 1/2. So we get the ordered pair x as being negative 1/2. Y is 1/2. There's our first ordered pair. Coming over here, we're going to put 2 in for x. So we get 3 times 2 minus y equals negative 2. We get 6 minus y equals negative 2. Negative y equals negative 8. Y equals 8. So we get the ordered pair 2, 8. And so in these problems here, generally you're going to get 2 or 4 solutions. And so this is a system of nonlinear equations because one or both of the equations are nonlinear. There's another example. Here we're going to use elimination. Here we have x squared plus y squared equals 13, and we have x squared minus y equals 7. Now notice in this one I could use substitution because I have a y by itself. I could very easily do that. But I'm going to choose to do elimination. I'm going to choose to multiply the bottom equation by negative 1, which will give me negative x squared plus x squared, which gives rid of the x squares. This gives me a positive y. This gives me a negative 7. So when I add the two equations together, I get y squared plus y equals 6. If I then take that y squared plus y equals 6 and subtract the y over, I get y squared plus y minus 6 equals 0. This factors into y plus 3 times y minus 2, which tells me y is negative 3 and y is 2. Just like we did in the other equation, I'm going to pull an equation from the original. I'm going to choose x squared plus y squared equals 13. And what I'm going to do is I'm going to substitute negative 3 in for y, and then I'm going to substitute 2 in for y. Same equation. Here's where I'm substituting negative 3 in. I get negative 3 squared, which is 9. Subtract the 9 over, I get x squared equals 4. I get x equals plus or minus 2. So I go 2, negative 3, and I go negative 2, negative 3. Here I have two solutions. Then I'm going to take the 2 for y and substitute it into the y squared. I get x squared plus 4 equals 13. X squared equals 9. Take the square root, I get x plus or minus 3. So now I have 3, 2, and negative 3, 2. So in this particular example here, or this particular system, I get 4 solutions. And that's because both equations were nonlinear. Think about this. This is a circle. This is a parabola. So what's happening is the parabola is intersecting the circle in 4 points. Over here, this was a line, 3x minus y equals negative 2, with a parabola. A line can only intersect a parabola in 2 points. That's the reason this had 2 solutions and this had 4.